So this is my extra credit video on Charles Law. So I'm doing my video on Charles Law. So what we're going to do is we're going to put water inside of this can and let it heat up on the burner. And we'll wait until water vapor comes out, and then we'll put it in cold water, and then we'll see what happens. It'll collapse. So we poured water into the can, and now all we have to do is wait for it to start boiling, and we'll see the water vapor come out of the top. As you can see and hear, the water is boiling, so the water vapor is coming out of the top. So what we're going to do is we're going to put it in ice cold water here, and because it's going from drastically so hot to so cold that it will crush the can. Because Charles Law relates the temperature of a gas to the volume of a gas in a closed system, which means that the relationship between temperature and the volume is a direct one, that as the temperature increases, the volume increases, and as things heat up, they expand. So because the can is expanding, because everything inside it is heating up, once we put it upside down in the cold water, the vapor will have nowhere to go, so it will crush. See, it was an instant thing. Like, it didn't even take any time at all. The formula for Charles Law is V1 over T1 equals V2 over T2. So volume 1 over temperature 1 equals volume 2 over temperature 2. And some applications as well for Charles Law would be a car engine or a gun. This is what the balloon looks like beforehand. Take note of the size. Charles Law relates the temperature of a gas to the volume of a gas, as I've said, and because the temperature of the gas inside this balloon is room temperature, if we put it into the freezer, which is much colder than here, then the volume will go down as the temperature goes down. So we're going to put this in the freezer, and then we'll show you that it looks visibly littler because the volume gets smaller. And now it's been a while, so we'll see that the balloon did get smaller. You might not be able to tell, but the balloon did get smaller because the volume went down because the temperature went down. And because this is Charles Law, as the temperature decreases, the volume will decrease.